Okay, greetings guys once again, and welcome to another awesome edition by iCampSA. In this edition, we are going to be looking at a homework problem which is based on geometric sequences. So this problem, as you can see, it requires our understanding of sigma notation. We are required to determine the value of P. Let's go to the next page and have a look at how we solve this problem. So there's a couple of things which we need to make note of, which is that the sum which we are looking for here is a sum to infinity. So if you look at our problem, just quickly, we have k equals p, and then the top we have infinity. Then we have 4 times 3 to the power of 2 minus k, and then this equals 2 over 9. So the first thing that we need to make a note of is what we have here at the top. What this tells us is that we are finding the sum to infinity. And now what we need to go and remember is, how do we find the sum to infinity? And you should remember that the sum to infinity is always given by a divided by 1 minus r. Okay? Where, if you do remember, our a equals our first term, and our r, that is our common ratio. So it means from what we have here, in order for us to find what this is equal to, we need to figure out what is a and what is r. Okay, so to find a, it's very easy because we use what we have here. So if you remember, what sits here at the bottom tells us where our sequence starts. So when we have k equals p, that means our sequence starts at k equals p. What does that mean? It means that the first term, which will be a, it will be at 4 times 3 to the power of 2 minus p. Okay, that is what the first term is. All what I did was take the k here and replace it with p there. Okay, then what I need to figure out is what is the constant ratio. Okay, now let's quickly manipulate this first, or maybe let's start by doing so. So if you look carefully, our Tn, which is our general term, it is 4 times 3 to the power of 2 minus k. And if you observe carefully, how we can rewrite this is 1 times, I'll have 3 to the 1, and then times 3 to the power of 1 minus k, like this. And then let's use tk. And then you'll see that our tk will just be 4 times the 3, which will give us 12. And then times, what I'm going to have is 3 to the power of minus 1. Then I change this to k minus 1. Okay. Then what you will see is that I now have my tk equaling 12 times, if you observe carefully, 1 over 3, all to the power of k minus 1. So now when it is in this form, I can easily see what our r is. So if you observe carefully, the r value is 1 over 3. But for the first term, if you remember, I just need to go and substitute what we have here. So for the first term, which is T1, we just substitute wherever we see Kp. So I can go and do so. K T1 will be 12 into 1 over 3 into our P minus 1. So really nothing changes here. Okay, it's still the same thing. It's equivalent if you try and work it out. So this here and this T1 here, which is A, these are the same. So with this sorted now, let's go ahead and quickly find our sum. So we know that our sum to infinity will be A divided by 1 minus R, which means for our problem, what we are going to have is, I'm going to use the first one. It is 4 times 3 to the power of 2 minus k, all divided by 1 minus 1 over 3. Okay. Now, if you quickly work out the denominator, what you will find is that the answer will be 2 over 3. So meaning we can multiply now by 3 over 2. So we'll end up having 3 over 2 multiplying 4, multiplying 3 to the power of 2 minus k. And there's terms that are going to cancel. So our sum to infinity will be the 2 will cancel with one of the 2's here, leaving 1, 2. And then the 3 will multiply in there and we'll end up having 2 times 3 to the power of 3 minus k. That is what we have as our sum to infinity. But remember that this is actually equal to 2 over 9. And what are we looking for? What we are looking for is p. So sorry, we were supposed to replace k with p, k with p. So this should be a p here. Okay, so if you observe carefully, we can now start solving by simply dividing by 2, divide by 2, and you will see that there's going to be cancellation. There's 2 and that 2 and that one. Then what we are left with is 3 to the power of 3 minus k, which is 1 over 9. And 1 over 9, we know it can be written as 3 to the power of minus 2. And guess what? Once the bases are the same, when we are dealing with exponents and powers, we just equate the powers. So what that means is we'll have 3 minus k equaling minus 2. So we can transpose the minus 2, transpose the k, such that if you look carefully, you'll find your k value as 5. So that is how we solve this problem here. What you needed to understand, which was very important, it is the following. So this here, by the way, becomes our answer. My apologies, this is supposed to be in terms of p. So let's quickly fix that. So that is minus p, minus p, minus p, okay? Which means we have p equals 5. And that is our answer. So what was important? What was important here was first determining the value of a, then secondly determining the value of r, then thirdly using our sum to infinity, equating it to 2 over 9, because we know that what is on the right hand side is what our sum to infinity should be equal to. I hope this does make sense. Give it a shot and see if you will get the same answer. Cheers.